All right, let's dive into an incredibly elegant solution to a really old, really stubborn problem. How in the world do you get water out of a solid wall? Well, the answer, as it turns out, is pretty wild. It involves turning the entire building into a giant, super low-power battery.
You know, that quote really just nails the whole issue. We tend to think of concrete and brick as these totally solid, impenetrable things, right? But on a microscopic level, they are a massive network of tiny little tunnels, just waiting to soak up any moisture they can find. So, before we can get to the truly brilliant solution, we've got to understand the enemy. Let's break down the destructive force of what's called rising damp. It's a real problem. Okay, think about what happens when you dip the corner of a paper towel into a spill. The water just seems to defy gravity, climbing right up the fibers. That's capillary action, and it's the exact same force that lets groundwater climb up inside the walls of a building, sometimes 1.5 meters high, or even more. But here's where it gets really nasty. See, the water itself isn't the main problem. It's just the delivery truck. The real lasting damage is done by what's dissolved inside of it. Corrosive ground salts, things like nitrates and sulfates. When that water finally evaporates from the wall, all those salts get left behind. Now, the stuff you can actually see, that white powdery stain on the bricks, that's called efflorescence. But the real villain here is subfluorescence. This is where the salt crystals grow inside the pores of the material. And as they grow, they expand, creating this immense pressure that literally shreds the brick and concrete from the inside out. Okay, so let's get into the science, because this is where it gets really fascinating. How do you fight this silence invasion? Not with brute force, but with a super clever bit of physics discovered all the way back in the 19th century. It all starts with this natural phenomenon. So, inside every single microscopic wet pore of a brick, the wall of that tiny pore has a slight negative charge. And what does that do? Well, it attracts positive ions in the water, creating this tiny electrically charged layer right up against the wall. It's like a natural super small electrical setup happening all on its own. And this is the aha moment. Way back in 1807, a physicist named Roos figured out that if you introduce an external electric field, you can actually control that charged layer of water. By making the wall positive and the ground negative, you can literally pull that layer of water molecules downwards. And because water has surface tension, that thin moving layer drags all the other water in the pore right along with it. This is the crucial insight. You're not trying to block the water, you're actively directing it. You're telling it exactly where to go. So the big question is, how do we take this cool scientific principle and turn it into a real working system? Well, essentially, you engineer a circuit where the building itself becomes a key component. You're building a battery the size of a house. The system is actually surprisingly simple. First, you've got a chain of special titanium wires. Those are the anodes, and they get embedded right into the wall. This makes the damp area positively charged. Then, a copper rod, the cathode, is driven into the ground nearby, creating the negative pole. And finally, a small control hub just regulates a tiny electrical current that flows between them. And when I say tiny, I really mean it. The whole system runs on an incredibly low voltage, usually somewhere between 3 and 12 volts DC. That's less power than what most toy train sets use.
The efficiency is just remarkable. The power needed to protect an entire building foundation from rising damp is less than what it takes to power a single modern LED light bulb. It's just an unbelievably low-energy, high-impact solution.
Now, just for a second, compare this surgical approach to the old ways of doing things. I mean, traditional solutions meant literally sawing a slot through the entire wall to stuff a plastic barrier in, or injecting all sorts of harsh, toxic chemicals. This electro-osmosis method, on the other hand, it's more like keyhole surgery. It's clean, it's non-destructive, and it's completely reversible.
So why does all of this matter? Well, this technology is having a truly profound impact on our ability to preserve some of our most important and our most fragile structures. You've got to ask the question, right? Where is a non-invasive, gentle, but super effective solution like this most needed? The answer, of course, is in our irreplaceable historic buildings. You see, the ancient lime mortars that were used in old cathedrals and monuments are really delicate, and they can be completely destroyed by modern chemical injections. Electroosmosis is perfect because it doesn't try to block up the pores in the wall. It actually allows the building to breathe just like it was designed to, while just redirecting the flow of moisture back down where it belongs.
Now, it's really important to understand that this isn't some kind of instant fix. It's a slow, steady process. Once the system gets switched on, it can take months, or for a really thick old wall, even a couple of years to fully dry out as all that moisture is gradually pulled back down into the earth. It's a marathon, not a sprint.
And you know, the technology isn't standing still either. The next generation of these systems are using what they call smart anodes that constantly measure the wall's moisture and then automatically adjust the power, which makes them even more efficient. Engineers are also pairing it with other tech to protect really sensitive modern places like data centers and archives, creating a complete defense against moisture.
And that really just sums it all up, doesn't it? Instead of fighting a force of nature with brute strength, this solution uses a deeper understanding of nature itself. It's a fantastic reminder that sometimes the most powerful solutions aren't about force at all, but about gently and very cleverly changing the rules of the game.